Hello students, in chapter 1 real numbers we can see the last topic revisiting rational number and their decimal expansion. So when you convert the rational number into decimal number, you can have a two form of decimal number. One is a terminating decimal number, another one is the non-terminating recurring decimal number. So you have rational number means always will be in the form of p by q. Q should not be, it's not going to be 0. In both case it's same only. But in terminating decimal expansion, your Q value will be different. Your Q, it's going to be either 2 or 5 or both only. But in a non-terminating recurring decimal expansion, Q will also have a factor other than 2 or 5. If you see example, you will get a clear idea about this concept. So first we can see this example 1 for terminating decimal expansion. So 13 by 10. 13 by 10 means just factorize this 10, you have 2 into 5. Then if you divide 13 by 10 for all whole number, the decimal point is at the end of the digit. So if you divide by 10, it's one digit move before, so you have a 1.3. Here like this, if you divide 241 by 100, so the decimal point is at the end of the digit, so 2 digits move before, so you have a 2.41. If you factorize this 100, you have 2 power 2, 5 power 2. In both example, your denominator is in terms of 2 into 5. Here also, so if you have your denominator is in terms of 2 into 5, you have your denominator is going to be in a tens power. So you have a terminating decimal expansion. In example 3, somewhat different. Here it is 3 by 8. If you factorize this, you have a 2 power 3. So here you don't have a factor 5. So that's why I am going to multiply the 5 power 3 in numerator and also in a denominator. So if due to this multiplication, your original value it's not going to be affected because you can cancel this. So you have a 5 power 3, you have the value 125. So if you multiply this, you have 375. Here both it's having a same power. So I can write 2 into 5 the whole power 3. So I can write 2 5s are 10. So 10 power 3. 10 power 3 means it's 1000. If you divide this, you have a 0.375. So you have a terminating decimal expansion. Here you are having only the factor 2. But anyway, you are going to have a terminating decimal expansion. In example 4, 13 by 125. If you factorize this, you have a 5 power 3. So here you don't have a factor 2. So that's why I am going to multiply the 2 power 3 in numerator and also the denominator. So you have here 2 power 3 means it's 8. If you multiply this, you have 104. Here you have the value 10 power 3, it's 1000. If you divide, you have the value 0.104. So what you understand here means, here you have the factor is only 5. But if only 5, that time also you have your decimal expansion is terminating. Now we can see the example for non-terminating recurring decimal expansion. Here 1 by 3, if you divide 1, you can't factorize, already it is in a factor form. So just to do the long division, if you do the long division, you have the answer 0.333, it's infinite. So this you can write 0.3 bar, that you have studied in 9th standard. So you in example 2, 77 by 210. 210 we can factorize. So if you factorize this, you have the factor 2521. If you do the long division, 77 by 210 means you have the value 0.3666. It's repeating. So we can write a 0.36 bar. So in this example, here the denominator is 3. You are having a factor other than 2 and 5. Here the factor, you have 2 and 5 and also you have the factor 21. That's why it is non-terminating. This is a non-terminating recurring decimal expansion. So from this, you are having, if it is a terminating decimal expansion means your Q value is either 2 or 5 or both. But If it is a non-terminating recurring decimal expansion, means your Q value is you have a factor other than 2 or 5. So from this we can conclude, the final conclusion is without long division, by factorizing the Q value, that is the denominator, we can conclude that when the rational number is terminating or non-terminating decimal expansion, that we can conclude. So this is if you understand the concept, you can complete this homework. That is in your exercise 1.4 first and second sum you can complete. Thank you.